Hi, Honors Chem. I'm doing a couple more problems from chapter 15, the equilibrium constant expression. There was a lot in this chapter that I really like to cover well. Le Chatelier's principle is going to come up in number 18, and solubility is going to come up in number 21. Please watch those videos several times for understanding, but let's go ahead and take a look. It's telling us that lithium carbonate is less soluble in hot water, and it wants to know if it's exothermic or endothermic, and what will happen if we raise the temperature. So let's look at this a little bit. First, let's go ahead and write our KSP expression. Now this, you'll have to do that for 19, so writing it here will help you know that. So first, let's write our solubility equation. Whenever you have a solid, it forms an equilibrium with its ions, and that's aqueous, and CO3 is -2, and that's aqueous. So you've written the equation now of what happens when it dissolves. So if you remember the equilibrium constant expression, only this time we're going to put the solubility product expression is, notice, we don't have that, so we won't have a denominator. So we're going to have Li plus squared times CO3. Okay, that is our expression. All right, so that will help you with 19, what I just did there. So let's look at Le Chatelier's principle. If it's less soluble in hot water, that means you're going to have more of the reactant because this is solid. Less soluble means more of the solid. So that means in hot water, at high temperature, the equilibrium is shifting to the side with the reactant. So if it's shifting to this side when you're adding heat, that must mean heat is in the products. So if heat is in the products, that would mean that dissolving this is an exothermic reaction, because the more you heat that up, the more it'll shift here and make it less soluble. Okay? Le Chatelier's principle is if you add something to the products, it will shift to the reactants. If you add reactants, it'll shift to the products. So if this had been endothermic, that means the temperature would be here. So if you cool it down or if you heat it up, it would shift and dissolve it that way. Okay? So it would be exothermic on that case. All right, let me just see where I am. Okay, now, if you start off with it colder and you heat it up, what's going to happen? For part B, it's going to shift it this way. So if you raise the temperature to 100 degrees, it's going to cause more of it to precipitate. So when the reaction shifts back towards the reactants, it's going to precipitate that. Now, I hope you've watched the videos on Le Chatelier's principle. There's a lot of things back and forth. If you add to one side, it shifts to the other. If you add to the other side, it shifts this way. If you remove something, it shifts to fill it back in. If you heat it up and it's exothermic, it shifts that way. If you heat it up and it's endothermic, it shifts that way because heat becomes either a product or a reactant. So if you don't understand this, please text me, but watch those videos and hopefully you'll be able to figure it out. I've put up the lab of Le Chatelier's principle, and you will see him do certain things. Try to figure out what he's added or removed. He may be adding something that reacts with something. For example, when he adds the silver nitrate, it actually removes, it reacts with the chloride ions in the reactants and removes them, so it shifts back this way. And you'll know what I'm talking about when you watch the video. All right, let's look over here. Silver carbonate has the KSP of 8.5 times 10 to the negative 12, solubility of 3.6 times 10 to the negative 2, and the molar mass there. And it is asking to calculate the KSP. So if we write this equation, we have silver. You should always start out by writing the equation. So we will have the silver ion, and that has a 2 in front of it because there's 2 of them. And then you have the carbonate ion, okay, and these are both aqueous. And aqueous and gases are the only things that are in the KSP expression. So the KSP expression will be silver squared times CO3, like that. Now, when we plug things in, we are going to say KSP equals X squared, and there's 2 of these, so you have to put a 2x in there. And then this will just be plain old X, because 1 mole of silver carbonate contains 2 moles of silver ions and 1 mole of carbonate ions. So the solubility, which is the X, the solubility is what you would put in for X. Now, why are they asking for the KSP if they've got it in the problem? I guess they just want you to figure it out using the solubility. So notice, this solubility is given in grams per liter. But this, by means of its brackets, is the concentration, and that's in molarity. Molarity is moles per liter. So we have to take 3.6 times 10 to the negative 2 grams per liter and divide it by this 275.81 grams per mole. Okay, and I put that grams per mole. We know from math, we can multiply top and bottom of my mole. So when we do this, we get 3.6 times 10 to the negative 2 divided by 275.81. We get 1.3 times 10 to the negative 4. So 1.3 times 10 to the negative 4 equals X, because that's our solubility in grams and in moles per liter, which is molarity. So you would go KSP equals 2 times 1.3 times 10 to the negative 4 squared times 1.3 times 10 to the negative 4. And when you do that, save time,